Hi everyone, welcome to my channel. This is the next part of optimizers. We have already discussed ADA grid. We are going to discuss about ADA delta and RmsProp. So these two optimizers are basically same. Actually this is the advance of ADA grid. So the things which were disadvantaged in ADA grid, actually we are treating this in the RMS prompt and ADA. Okay. So what we learned? So basically in ADA grade we are just updating the learning rate, right? So here actually what happens? Let's talk about the disadvantage of ADA grade. Uh, so basically, we were taking alpha T earlier in ADA grade. So actually, with few repeated iteration, this alpha T was getting very much higher. So for that actually the new learning rate was becoming null. It was close to zero, so there won't be any weight update possible, because it would be same, right? It would be same, the new weight and the old weight would be same if this particular value goes to zero, right? So basically we're treating this on a learning rate. So how we're going to treat it? So let's see. So instead of taking alpha t that we are taking in ADA grade, we are taking one exponential weighted average. So we're taking exponential weighted average in new learning rate. So don't think as it is a momentum, because in momentum what we do, we just take exponential weighted average here in part of loss, like derivative of loss and weight. But here actually we're just taking exponential weighted average to avoid this part going very high. So we just try to avoid that by using exponential weighted average. So this is not momentum, as we learned SDD with momentum. So we are taking also exponential weighted average in that particular optimizer, but here SDW, that is exponential weighted average, um, is taken to just avoid this part. This denominator part is going too much high. So okay, let's see. Okay, we have already discussed about exponential weighted average. So it is nothing but giving some importance to the previous iteration as well, right? So okay, so if we're taking this weighted average, by taking this formula, there is little bit change in this formula. In that SGD with momentum, we're taking the simple derivative loss with derivative weight. We are just squaring it uh, in the ADA delta or RMS form, right? So yes, for SGD actually, as we are taking, let's see, suppose initially actually SGW would be 0 for any iteration t. As you can see, if for t actually, if you are considering for iteration t, so the formula formulates like this. So beta into the previous timestamp SDW value to the 1 minus beta to that particular square of loss of derivative loss. So here actually, if you're taking 0.95 as beta value, so this part will be multiplied with 1 minus beta, that is 0.5. So 0.5 is nothing but very, if you are multiplying something to 0.05, it will be very much slow, right? It's not slow, it is very much small. So due to this, it is never gonna be so much high. The STW is never gonna be so much high. So this part is never gonna be so much high. So yes, we can avoid this denominator part going very high in ADA grade. So yes, in this way we can treat this denominator, and we can apply this to the new learning rate, and we can update our weight using the traditional weight up weight optimization formula. So just remember one thing, here we're not using exponential weighted average as momentum. Actually, we are using momentum and this updation of learning rate in last optimizer, that is Adam optimizer, and that Adam optimizer is basically the best optimizer till now. So we are using both the advantages of RmsProp as well as the momentum that we are using in SGD with momentum optimizer. So this is all about RmsProp. So thank you guys. Thanks for watching.